And pick up on the next voting method, which is called board account. In board account, points are assigned to candidates based on their ranking. Yes. 1 point for last choice, 2 points for second to last choice, and so on. Point values for all ballots are totaled, and the candidate with the largest point total is the winner. Okay, so a group of mathematicians are getting together for a conference. The members are coming from 4 cities: Miami, Pensacola, Tallahassee, and Gainesville. The votes for where to hold the conference were as follows. And you can see, looks like Miami got the most first place votes, which is also a majority of the first place vote. However, and here's how it works. Looking at this here, Tallahassee is given 1 point. Actually, it shows it down here, doesn't it? Tallahassee is given 1 point, and there's 51 of them, so Tallahassee gets 51 points. Gainesville, which came in the second to last, 2 points per 51, so 102. Pensacola came in second choice, so that's 3 points, 153. And Miami came in first, so that's 4 points, for a total of 204 points. And we've done that for every result. Then we go through and we add all the points for each city. And we find that Miami ended up with 253 points, Pensacola 325, Tallahassee 194, and Gainesville 228. So by the board account method, Pensacola is the winner of this vote. Anybody see a problem with that? Well, according to board account, no, that's what it is. However, remember there was 100 votes. Miami received 51 of them, 51 first place votes. And if you remember, take 100 divided by 2, we get 50, so we round up to 51. 51 votes makes a majority. So Miami received a majority of the first place votes, and yet it did not win by this method. Yeah. Basically, Pensacola came high up either first or second for all of them. So they got more points. Whereas Miami, if you look down here, Miami came in last place on all those. So, didn't even say it. So essentially, the city that received the most first place vote, not just the most, a majority of the first place votes didn't win. Sounds to me like there's something wrong with that. I mean, again, we say up front what voting method we're using, so, you know, things like that can happen. So let's go back to this. And we'll find the winner using board account. So let's see. Let's look here at goings. So 1 point for third place, 2 points for second place, 3 points for first place. So just looking at goings for now. 3 points here for 40 times 44. And here, 3 points times 14. Here, 3 points times 20. Here, 2 points times 70. Here, 1 point times 80, no, 80, 22. and here, and here 1 point times 80. And what's that? 132, 42, 60, 40, 22, and 80. I should have just made a new table. So adding this up, 132 plus 42 plus 60 plus 40 plus 22 plus 80, and we get a total points of 376 for goings. Okay, so now let's look at McCarthy. Here we have 2 times 44, 88. Here we have 1 times 14, which is 14. They're not here. Here we have 3 times 70. Here we have 3 times 22. That's what, 210 and 66. And here I have 2 times 80, which is 160. And again, nothing here. So we'll add our total up here. 88 plus 14 plus 210 plus 66 plus 160. And I get 538 points. And then lastly, we look at Bunny. Here we have 1 times 44, which is 44. Here I have 2 times 14, which is 28. Here I have 1 times 70, which is 70. Here I have 2 times 22, which is 44. Here I have 3 times 80, which is 240. And here I have 3 times 39, which is 127. Adding it up, 44 plus 28 plus 70 plus 44 plus 240 plus 127, and I get 553. Bunny wins per board account. Everybody follow that? Any questions on board account? I think there may be another one. Oh, nope. This goes to what I was talking about. Something called the majority criterion states that if a choice has a majority of first place votes, that choice should be the winner, which was what I was saying earlier. And then the previous election using board account violates the majority criterion. This also automatically means that the Condorcet criterion will also be violated, as Miami would have been preferred by 51% of the voters in any head-to-head comparison. So again, our voting method has flaws. Brings us to our next method, Copeland's method. And this method, this is similar to the Condorcet. In this method, each pair of candidates is compared using all preferences to determine which of the two is more preferred. The more preferred candidate is awarded 1 point. If there's a tie, each candidate is awarded half a point. After all pairwise comparisons are made, the candidate with the most points and hence the most pairwise wins is declared the winner. So we're going back to Anaheim, Orlando, and Hawaii. So just like in the Condorcet method, we do pairwise pairing. Anaheim versus Orlando. Anaheim is preferred over Orlando here. here, and here. So Anaheim is preferred in 7 versus, let's see, 7 versus 3, Anaheim over Orlando. So Anaheim wins this pairwise compete. So Anaheim has 1 point. Okay, makes sense? It was preferred over Orlando. It gets the point. Now we look at Anaheim versus Hawaii. Here, here. So that's 4 versus here and here, which is 6. So in this case, Hawaii wins. So Hawaii gets 1 point. So far, so good. Okay, and lastly, we have Orlando versus Hawaii. So we have Orlando preferred here and here, which is 4, and Hawaii preferred here and here, which is 6. So Hawaii is preferred, so Hawaii gets another point. So Anaheim has 1 point, Hawaii has 2 points, Hawaii wins. This is a little less picky than the Condorcet, because in the Condorcet, you have to win, be preferred over all the other competitors. In this, you just have to get the most points. With so few, it's pretty much going to come out cut and dry. But had there been more candidates, it might have come out with a tie even. So any question on Copeland's method? Here we go. Considering the advertising group's vote we explored in example 7, determine the winner using Copeland's method. There's 5. Here's the issue with this method when it comes to using it with larger numbers of candidates. We have 24 head-to-head comparisons to do here. So unless somebody really needs to see it, I was going to skip it. Thank you. So let's go back to this one. This one I don't mind doing. So let's look at this one using Copeland's method. It says here, since we have some incomplete preference balances, our ballots will have to adjust. For example, comparing M to B will ignore the 20 votes in the third column, which do not rank either candidate. Likewise here, when it comes to G and M, we'll ignore those votes as well. So let's look at this. So I have G versus M. G is preferred here, 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 and that's it, right? Which is 78, where M is preferred everywhere else. 150, 211. So M wins, M gets 1 point. All right, now let's look at G versus B. Here, here, and here. G is preferred here as well. So that gives us 148. And B is preferred here, here, and here, which is 141. So in this case, G is preferred. So G has 1 point. So far, so good. And now we're going to look at M versus B. M is preferred here, here, here. And remember, we ignore this because neither of those are in there. So what's that, 90? 92 plus 44, 136. And B is preferred here, here, and here. Verse 133. So again, M takes that one. So M gets a second point. M has 2 points to 1 for G, so McCarthy wins. Any questions on Copeland's method? Yes. Go ahead, somebody. In this method, if you count them, if goings is involved. So here and here, I counted them. They went to goings. But if it's this one, you don't count them. Because neither of those, neither one of them won. Neither one of them were on there. Same here with Goings and McCarthy. Neither one of them are on there. So how could Goings or McCarthy win? Or be a preferred over the other? They don't want them at all. Was that your question as well? Any other questions? So what's wrong with Copeland's method? Well, the committee is trying to award scholarships to one of 4 students. Anna, Brian, Carlos, Dimitri. Votes are shown below. So they were nice enough with all these to do the choices for us. So making the comparison, A versus B is a 10-10 tie. So A and B get 1 point or half a point each. Ties, you get half a point. A versus C ended up with A winning and getting the point. A versus D, D wins and gets the point. B versus C, C gets the point. B versus D, B gets the point. And C versus D, C gets the point. So what we end up with is A has 1.5 points, B has 1.5 points, C has 2 points, and D has 1 point. Looks good, right? However, so in this case, Carlos gets 2 points. So Carlos is awarded the scholarship. However, the committee then discovers that Dimitri was not eligible for the scholarship. Evidently, he failed his last math class. Even though this seems like it shouldn't affect the outcome, the committee decides to recount the vote, removing Dimitri from consideration. This reduces the preference schedule to this. Now looking at it, A versus B is a split. They each get half a point. A versus C, A gets the point. B versus C, C gets the point. A has 1.5 points, B has a half point, C has 1 point. So now Anna's the winner, which leads to yet another fairness criterion. The independence of irrelevant alternatives criterion. If a non-winning choice is removed from the ballot, it should not change the winner of the election. In other words, if choice A is preferred over choice B, introducing or removing a choice C should not cause B to be preferred over A. Oh, did I tell you guys I do not ask for definitions? I'm not going to ask you to tell me what the independence of irrelevant alternatives criterion is. So you don't have to worry about memorizing that. So what's the fair method? Everything we've done so far has had an issue. Well, so Arrow says, with Arrow's impossibility theorem, states roughly that it is not possible for a voting method to satisfy every fairness criteria that we've discussed. So there isn't one. which is why, again, I say up front, you must disclose what voting system you're going to use, what method. That's the closest to fair you can get, but all of them have their issues. We can look at another one here. A, B, and C. Notice that in this election, 10 people prefer A to B. 5 here and 5 here. 10 people prefer B to C. 5 here and 5 here. And 10 people prefer C to A. 5 here and 5 here. So no matter who we choose as the winner, 2/3 of the voter would prefer someone else. This scenario is dubbed Querseth's voting paradox and demonstrates how voting preferences are not transitive. Just because A is preferred over B and B is over C does not mean A is over C. There is no fair resolution in this election. So that brings us to our last voting method. Approval voting. So here's how this works. A group of friends is trying to decide upon a movie to watch. 3 choices are provided, and each person is asked to mark with an X which movie they are willing to watch. In other words, I approve of this movie, I don't approve of this movie. If you approve of it, you put an X. So now what we do is count across for Titanic how many people agreed to it, that they're willing to watch it. I think it was 5, yeah. And Scream was 6, and Matrix was 7. So 7 of the 10 people preferred, or well, not even preferred, they're willing to watch it. I've seen it 100 times, but heck, I'll watch it again. Doesn't necessarily prefer it. So that's how approval voting works. We have another example here, yeah. So going back to our mathematics, our mathematicians deciding on a conference location, they decide to use approval voting. Votes are tallied below. Find the winner using the approval voting method. So what I do is I add across. So I have 30 plus 10 plus 15 plus 5. All right, 30, 10, 15, 5. That's 60. And here I have 30, 15, 20, 15, and 5. 25, 6, 7, 80, 85. And here I have 10 plus 20 plus 15 plus 5. What do you have? 50. And lastly, I have 15 plus 15 plus 5, which is 35. So Pensacola is the choice by the approval method. And 85% of the people prefer it, so, or approve of it, so that turns out pretty good. However, what's wrong with approval voting? Consider this voting schedule. Clearly, A is the majority winner. 80 out of 100 votes choose A as their first choice. Now, suppose that this election was held using approval voting, and every voter marked approval of their top 2 candidates. So A and B were approved, B and C were approved, C and B were approved. Now A would just receive these 80 votes. That's the only time they're in the top 2. B, on the other hand, is in the top 2 on everyone, so that would be 100. And C would only receive approval on 20. So B would be the winner. So the theory behind this is approval voting tends to vote the least disliked choice rather than the most liked choice. And you can see it because A is liked by 80%, but B in this case is liked by all of them. It's not top choice. So that finishes this chapter. Seeing as how we're already a week ahead, I need to reset up the schedule for this next semester. Are there any questions on voting? Here, yes.
For the for the test, will we have to know, like, remember how to do each one?
Okay, yeah, I guess that's a good question. I was actually getting to that, but I'm glad you asked because I was also forgetting to get to it. So 2 things about the test. Number 1, you may have noticed there's a study guide for each test in Canvas. That study guide is basically exactly the same as the test. And I haven't looked at it since last semester, but if I remember correctly, I know there's not more than, if memory serves me right, there's a plurality question, a plurality method and a Condorcet method. I think just what's in the homework. So no, you won't need to know all of these. Some of them, it would be kind of counterproductive to put on an exam because they take so long to do. So any other questions about voting, about problem solving, about the course in general? Everybody's good? Well, that was easy. So next week we will cover weighted voting. And then I don't know what we're going to do the week after that. Maybe twiddle our thumbs. I don't want to get ahead. I don't want to take the test early because it's kind of there, but I don't want to get ahead either. So we'll have to figure something out. Maybe we'll just play a great big game of Monopoly. No, doesn't sound like a good idea. Yeah. Let's see. Lauren. All right. Anybody see Emma or Wesley online? Okay, nope. I don't need this anymore.